Hi, Chem Peeps. We're continuing our final exam review for first year chemistry. We're going to talk about electron configurations and a little bit of quantum numbers today. Looking at my screen, I have some things here on the left. I have the diagonal rule for writing electron configurations. I have this periodic table that shows the last configuration of each element on the periodic table, and then I have some notes on what the quantum numbers mean. So we will address these things on the left as we need them. So let's look at question 24. It says, which statement regarding red and green light is correct? And you're like, why are we talking about red and green light? Because the electrons, when they get excited, my pen does not want to write. When electrons get excited and they jump up energy levels, they relax back down by releasing light, and we can analyze that light that they give off to get lots of information like how much they jumped, how much energy was absorbed, and so on. So with the Roy G. Biv, the electrons of the color part of the visible light of electromagnetic radiation, red light has about 700 nanometer distance for its light. Okay, my pen just is being stubborn. And then we get all the way down to violet, it's about 400. So visible light or colored light is going, or visible light, which is made up of the colors that I have listed here, red, orange, yellow, green, blue, indigo, and violet. They run from 700 nanometers to 400 nanometers. That means if I could diagram what the wavelength looks like, red has very long meandering waves, and violet is very short. Okay, and that's very exaggerated what I've drawn there. But because this one is short and covers such small distance, it then has a higher frequency. Okay, this one is covering a great distance, but it has a slower frequency or a lower frequency. Frequency is how many times a wave passes a point, and it is not the same thing as speed. All of these colors, all of the energy that comes from the electromagnetic radiation from our sun travels the speed of light. So they have the same speed. So looking at this question, green light's frequency is going to be higher than red light. And so D is the correct answer. We would not choose A because they have the same speed of light. The wavelength of green is shorter, and the energy does not go into this. We're talking about wavelength and frequency here. Okay, 25. A spectrum that is unique to a compound or an element is called. So there's two types of spectrums. There is bright line spectrum and continuous. Continuous spectrum has all these colors with no separation. Okay, they kind of blend. They kind of blend from one to the other. Where bright line is like a fingerprint. Okay, it can identify. So that's how we know, like, we've never traveled to nebulas and planets so far away, but yeah, we know what's in their atmosphere as far as gases. That's because we're analyzing the spectrums that come from looking at them through a spectroscope. Okay, so a fingerprint, it's going to have, like, for example, if I'm looking at a unique element that's giving off a light, it might have a red band, and then maybe it has a green band, and then maybe it has a violet band. And these three bands, and in between, it's black. So I just have bands of color. And so the answer here is going to be A. Okay, so let's go to 17 over on the right. 17 says, what element has an electron configuration of 1s2, 2s2, 2p4? So we can cover this in a couple ways. First way, know your periodic table. This element here is landing on 2p1. Remember that each row of the periodic table corresponds to an energy level in the atom. Okay, so there's 7 rows, 7 energy levels that we currently have atoms that fill. This is supposed to be a 6. Okay, so, and P clouds have room for 6 electrons. And guess how many boxes across here on the periodic table there are? 1, 2, 3, 4, 5, 6. And so this box right here is the 2p1, which is boron. So our answer is C. The other way that you could discern this is to count up the electrons in the configuration and find that on the periodic table. So if I count the electrons that are in this, I would have 2 plus 2 plus 1, that is 5. And again, on the periodic table, that's boron. 18. How many valence electrons are in the configuration of 1s2, 2s2, 2p4? Valence means outer energy level. And so if we look at this configuration, the highest energy level achieved here is 2. So we have a 2s2 and a 2p4. That means there are 6 valence electrons in this one. So the answer is C. 19. Which electron configuration is correct for calcium? So if you look calcium up on the periodic table, it has an atomic number of 20, which means it has 20 electrons. It is also found, I guess I could open that back up again. If I look at the periodic table, it is found, calcium is found in the 4s2. So it's going to be the box that is right here. So I can follow the diagonal rule until I get to 4s2, or I could just read the periodic table. But if I just quickly look at my choices here in this problem, the only one that lands on 4s2 is A. Be careful, though, that they're written correctly. You could have all of them landing on 4s2, but they're not written correctly, and you want to make sure you pick the one that's correct. So if I check this, it does match the diagonal rule. Okay, 20. The major difference between a 1s sublevel cloud and a 2s sublevel cloud. So let's just quickly talk about the anatomy of an atom. In the center, we have a nucleus, and then we have energy levels that come out. Okay, and I'm only going to go to energy level 4. And each energy level gains another cloud. So the 1 has room for an S cloud. The 2 has an S and a P. The 3 has an S, a P, a D. And the 4th one has S, P, D, and F, and so on and so forth. And if we look at this, the S can hold 2 electrons max. P can hold 6 electrons max. D can hold 10 electrons max. And F can hold 14 electrons max. So they all hold, the S's in all 4 levels, and all 7 levels that the atoms currently fill, they have the same number of electrons. S holds 2. The 2s has a slightly different shape. That is incorrect. The S is spherical in shape. The P is dumbbell in shape. The D is donut shape. And F is fancy shape. So they have the same shape. The 2s is at a higher energy level. That is true. So as we go up energy levels, the energy increases. So that is a true statement. And the 1s can only have 1 electron. That is false. So the answer here is C. From the following elements, which one will have 2 of the 3 p orbital boxes filled? Okay, so let's talk about what that means. So these clouds have orbital boxes. So the S can have 1 box. The P can have 3. The D can have 5. And I'm drawing these out because I'll be using them in the next question. 5, and then the F can have 7. Okay, and if you remember from class, 1, 2, 3, 4, 5, 6, 7. From class, we can put an up arrow in and a down arrow in each box. And those arrows signify electrons. Remember, we can have 2 electrons in the S cloud. Well, they can have an up arrow and a down arrow. So if we go to the P box and P boxes here and talk about them, when you fill them up, you're going to put 1 per box because it reduces repulsion energy. Then you double up. And so if I want to fill 2 of the 3 of these, that means I'm going to have 5 electrons in that P box. That means I am going to be filling or looking for an element that has 5 electrons in the P. That is going to be, that is going to be family 17. So that's the halogens. So let's see what we can find in the answers that would line up with halogens in the, what does it say? What are we on? 21. 2 to the 3p orbitals. Well, 3p is going to give me chlorine. Chlorine lands on 3p5. Okay, so that's the answer there. Which students often miss that question. Okay, 22. When the principal quantum number n equals a value of 4, then the number of possible sublevels is. So this is a question that a lot of my students miss, but they don't understand what the different quantum numbers tell me. So n represents the energy level. Okay, so right now we have energy levels 1 through 7. Azimuthal, which is basically the electron clouds, and in this case, it's being called the sublevel. So they can be called sublevels. They're not the energy level, but the sublevel. We can have an S cloud, which is signified by a 0, P with a 1, D with a 2, F with a 3. The magnetic quantum number represents those box numbers. So we just looked at the 3P. The center box is always a 0. Then we number out like a number line. So those numbers that number the boxes will be the M quantum number. And then the spin, if I have an arrow in here that's pointed up, like here, that would have a +1/2 value. And if I had one that's pointed down, that would be a -1/2 value. So that's what the quantum numbers are. And I do have a video on that if you need to brush up on quantum numbers. So let me just get this minimized. So if we look at the question, it says, how many sublevels would n have? Well, we kind of drew it out here. I've erased it, but I still have it right here. We have the S, the P, the D, and the F. So we would have 4 sublevels. And then 23 says a flame color test of an element is caused by the energy released when electrons are doing what? Well, when electrons in an atom absorb energy, like when you're doing a flame test, they do jump. So if this is the nucleus, and this is energy level 1, this is energy level 2, and I have electron here, it's going to jump up. But we don't see that. But eventually it's going to come back to its original state, and that's when we see the unique flame color come out. So it's when they're relaxing back down. So it is A. So that is my review of my final exam that I would use electron configurations and quantum numbers on. Do have another video that I taught it earlier in the year. You can find that. Give me a like, give me a share, save it, leave me a comment. But you can find more information on TikTok and YouTube at Chem's Chem Chats. I hope that helps, and I will see you in the next video.